Shu Jie, matrix number AP210206, student from BPC 22303 Manufacturing Process, Section 1. The advanced machining that I chosen is Electrical Discharge Machining, EDM. It is a manufacturing process that removes material from a workpiece by applying a series of current discharges between two electrodes separated by a dielectric bath. So, how does the EDM machining process work, and what are the advantages and disadvantages of EDM? First of all, let us take a look on how does EDM machining work. EDM process uses thermoelectric energy to erode workpieces due to rapidly recurring sparks between the non-contact electrode and the workpiece. The discharge current flows from between the electrode and the workpiece through the small distance between them called a gap, which is filled with the dielectric fluid. Dielectric fluid also simultaneously flushes the gap continuously during the machining and carries away debris and restores the sparking condition in the gap. A proper gap is carefully selected to a value such that it generates such current by breaking down the dielectric film under a set voltage. There are no cutting forces used between the electrode and the workpiece as there is no contact between them. This condition eliminates the vibration and problems arising due to the machining forces. The EDM process is used for making different kinds of workpieces. The EDM machine is programmed for vectorial, polygon, spherical, circular, helical machining cycles, and so on. These different machining cycles are used for making parts and are presented in the figure. Next, EDM has a few advantages over conventional machining. First and foremost, it can produce any hard, soft, tough, and brittle conductive materials, and the electrode is easy to process. Because EDM removes materials by the heat energy of pulse discharge, the machinability of materials mainly depends on the conductivity and thermal properties of the materials, such as melting point, boiling point, thermal conductivity, etc., but is almost independent of their mechanical properties. EDM can be used to machine hard workpieces with soft stools, and even to machine super hard materials such as polycrystalline diamond and cubic boron nitride. At present, electrode materials are mostly pure copper, brass, and graphite. On the other hand, EDM is suitable for machining special and complex shaped parts. Because the tool electrode does not directly contact the workpiece during machining, and there is no cutting force during machining, it is suitable for machining low stiffness workpieces and micro machining. The shape of the tool electrode can be simply copied to the workpiece, especially suitable for machining workpieces with complex geometric shapes such as complex cavity mold processing. The adoption of numerical control technology makes it possible to process complex shaped parts with simple electrodes. However, there are several disadvantages of EDM. EDM is mainly used for processing conductive materials such as metals. Certain conditions are required for processing semiconductor and non-conductive materials. Generally, the machining speed is low, so the cutting is usually arranged to remove most of the machining allowance, and then the EDM is carried out to improve the machining efficiency. Move on to the last part of this video, which is the applications of EDM. EDM is mainly used in the tool and die industries. Today, EDM is an integral part of the process for making prototypes and production parts. Some of the applications of EDM are presented in the figure. That's all from me. Thanks for listening and have a nice day.